So, dear participants, welcome back to our laboratory sessions. Actually, this is experiment number 13 of BVOC Industrial Automation first year. If you get into your syllabus of IA syllabus and go to the course code IAVOC 105, that is the practical paper, you can find that there are three sections, in which in section 1 there are experiments on various aspects of analog electronics and digital electronics. We have already gone through a demonstration of digital logic gates, which was actually part of experiment number 13. So here we can see that if you go through the lab manual, there you will get the basic theory of different types of logic gates, and definitely that is also carried out in your theory coursework. And here actually we have already conducted this experiment on Luan's Electronics kit F07A, where we have seen the working of logic gates. In this session, we will get introduced to a more generic digital trainer platform through which we can actually build any digital circuit. Definitely, logic gates are very fundamental parts of that, and we will also develop the logic circuits that we have already studied through this particular experimental kit. So here this is the digital trainer regarding which we will be discussing today. This is Omega Electronics. I will try to rotate this. This is actually digital electronics, a digital trainer kit Omega DL1044. This is a very generic platform in which every facility has been given so that you can build your own circuit to perform the digital experiments. This is a breadboard based kit so that no soldering is required. You can simply add jumpers and accordingly you can build on your own circuit. Before performing any experiment, what we will do, we will have a very clear idea of various blocks of this trainer first, and later onwards whatever we will study here in this video, I must say that you people should corroborate it with the details that is already given in the manual. So in manual there is very comprehensive coverage of each and every block, so that you should get into. Okay, so now let us get into the actual part, that is the demonstration of the working of this digital trainer. So as I have already told you, this is Omega Electronics MEC DL1044, a digital trainer platform. You can see in the center part there is a breadboard. There are actually two breadboards here. This is breadboard 1 and this is breadboard 2. So you have got this ample space to build up your own circuits. Now why this is called a breadboard? Because you can see there are perforations just like a bread. Okay, so these are the perforations in which we can actually build up any circuit. Okay, you can see here this is just a resistance. This is a resistance, okay, that I wanted to put in one of the perforations. You can see I can put the resistance like this. The resistance will get connected. You can see here the resistance is connected. Okay, likewise I can connect anything. I can connect an LED maybe like this. So it becomes very easy for you to connect anything. I feel that. Okay, fine. So you can connect this LED like this. So anything that you want to connect to this board, it is very easy. You need not to go for any soldering or any other sort of tie up. Now you can see here, I will show you that how this breadboard is having its construction. You can see that here there are many perforations like this. Okay, this is one line, this is another line, this is the third line, fourth line of perforations. Remember one thing, that within this part, this much part, okay, I am talking of this much part. If I call this as section A, this is section A, this is section B, this is section C, and this is section D. Okay, if I call it like that, then we can say that in section B and C, this section B and C, we actually use to build our circuit. Okay, and this section A and section D, they are meant for making your power lines. Remember here in section A and section D, you have got these perforations interconnected. These are interconnected horizontally. These are interconnected horizontally. However, you can find very easily that here there is a smaller gap between two series of perforations and there is a bigger gap. Remember that although these things are internally connected, there is no connection between this line and this line. So if you want to connect this line and this line, what you need to do? Very simply, you need to put jumpers here. Now here you can see that in order to make circuits, you need a very special type of wire. This is what is called as single strand wire or hook up wire. So this is having only one wire inside the insulation. Okay, so this you have to remember, you cannot use multi-strand wires that we normally use for making circuits, for building up the circuits using a breadboard. So here you can see we can very easily insert this wire into some of the holes and we can connect it on other part, and in this way we can make interconnections. All right. Now as you have seen in this block A and block D, because this is just a repetition, this block A and block D, these connections, these perforations or these holes they are connected internally in horizontal manner. So there is line 1 and line 2. So what you can do, you can connect this line 1 to 5 volt and you can connect this line 2 to ground, and this becomes a complete line of 5 volt. You can take as many connections that the number of perforations or boards support, holes support, that much lines you can take into the circuit, and the other line you might take for the ground. So one line becomes your 5 volt or power supply line, other line becomes your ground line. So whatever necessity of the circuit is there to connect power supply or ground, you can take the jumper wire directly from this part to this part. Now let us get into the circuit building area. You can find that cannot be seen right now, that there are some numbers written, alphabets written, A, B, C, D, E, F, G, H, I, J. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So these 10 horizontal lines are there that allows you to build up any circuit. Remember that this part and this part, they are completely isolated electrically. This part and this part. These are the two parts. They do not have any interconnection. However, remember that in each of these blocks, you will be able to see while performing the experiment that this line, they are interconnected. So in this case, the interconnection was horizontal, and in this case, the interconnection is vertical. These lines are connected like this. They are interconnected. Okay, so if I ask you to connect a resistance between point 1 and point 2, and if you do like this I am putting here, This is point 1, and another thing I am putting here, say. So you can see that these resistance is connected on the same line. So there is no goodness out of that, because this line is already shorted. So what you have to do, your line point 1 and point 2 should not lie on the same line. It should lie on different line. Okay, now you can connect it definitely. If you are on an horizontal modality, then you can connect it like this. Remember that in this block and in this block, in this block and this block, the connections are not horizontal interconnections. The interconnections are vertical. So each line is vertically connected, right, from inside. They are not horizontally connected. This you have to remember. So this is your block, and there is very good thing why this thing is there. This internal one trench is there, so that if you want to connect integrated circuits, if you want to connect integrated circuit or ICs, you can connect it very easily like that. Okay, because this is an IC. I will talk about the ICs later on. Okay, so you can connect it like this very easily. You can get them connected. So the ICs have terminals. So you can see each of the terminal. These are the terminals of the IC, 1, 2, 3, 4, 5, 6, 7, like that. So each of the terminals are having one dedicated line for them. There you can connect various objects to build up your circuits. Now let us get into the another part, other blocks of this board. Okay, so you can see this board is working on AC supply. So here you have to connect it to AC, and inside this board there are some arrangements so that the AC can be brought down to 5 volt DC. Once you power on that board, it gets the power, and every internal block of the board starts working. So I will start from this block number 1. You can see in block number 1 there is a pulse generator. There is a pulse generator. This is actually one thing that I had connected externally. There are two pulse generators. The pulse generators are given in the board in order to get a digital pulse of 5 volt of a given duration. The duration is 1 second. So once you push this switch and release it, you get a 1 second pulse. So let us see how it operates actually. For that, what we will do, we will take one LED. You can see this is one LED, and you can see very easily that one of the, I will take this thing so that you can see. Yeah, now you can see one of the lids is longer and other lid is shorter. And if you look like this in this particular modality, then you can find that one of the side of the LED is a bit notched. This is a notch. Okay, so if you look into the notch, you can find that the rest of the part is circular and there is a flattened part. There is a flat part. Okay, that flat part is on the side of the shorter lead of the LED. So remember that this longer lead is always the anode and the shorter lead is the cathode. Longer lead is a longer terminal is anode and the shorter terminal is cathode of the LED. So what I will do, I will connect the LED like this. Okay, I will connect the LED like this. You can see very easily that what I have done, I have taken one terminal on one side of the breadboard and other terminal on other side of the breadboard. Now remember that here it is very important. If you connect two terminals on the same vertical line, your LED will not work. It may get damaged after you connect the LED. Now remember that LEDs cannot be connected directly to 5 volt block, right? So for that you need to connect one series resistance of adequate value. Here I am using a 270 ohm resistance. This resistance is connected in series with the LED, okay, so that the LED cannot be damaged. And now what I will do, I will connect this thing, one terminal of the resistance. I will connect one terminal of the resistance to one of the pulse generators, and I will connect the cathode of the LED to ground. So this is a ground circuit. This is the ground terminal of the circuit. This ground is common everywhere. So I will put it into the ground. Remember that I am putting the pulse input to the anode of the LED and the cathode to the ground. So now your circuit gets completed. So what I will do now, I will press this button for a while. I will release it. Okay, there is a fault in the circuit. Yeah, now your resistance is connected to the LED. Okay, now you can see. Whenever I press it, when I release it, you get an 1 second pulse. I press it, then I release it. Remember that this characteristic is very important. This means that this pulse is a negative edge trigger pulse. So when I press it, right, this is not working. When I release it, it works. This is a negative edge trigger pulse. Okay, you can have pulse trigger, you can have a negative edge trigger, or you can have a positive edge trigger. This is the negative edge trigger. Now another block, there are two such pulse generators. The another block is the 5 volt power supply. That is a generic power supply you can use for different purpose in the circuit. As I have already told you, once you have the power supply in your hand, what you can do is very easily, you can take one jumper like this here, and another jumper like this here to the ground. So now you can see that your power supply line, that the positive 5 volt and the ground is ready up to this point. If you want the 5 volt line to be continued in this section and the ground line to be connected to this section, then you have to connect jumper wires. Okay, so in this way you can very easily connect the 5 volt and ground to your circuit. And now let us look into the other part. Here you can see that there is a variable clock. There is a variable clock. Let us see how this clock works actually. I will connect this to the high terminal, and here I will connect it to the ground. Now you can see the LED blinks. You can very easily see the LED blinks actually. Okay, so if I adjust this knob, then you can find the blinking rate changes. The blinking rate changes. I will do one thing. I will adjust the illumination of the room so that it becomes easy to see. Now as I vary this knob, you can see the LED blinking rate changes. Now the blinking is so fast that even our eye cannot follow it. Okay, so this is the working of this knob. Now you can find that there are two options. There are two options, as you can find it very easily here. One is low and other is high position of the switch. So when you press the switch, it is low, and when you depress the switch, it is high. So when it is in low condition, you have got the clock frequency range from 10 Hz to 40 Hz. And if you keep it on high condition, then your clock frequency range lies in between 1K to 20K Hz. Okay, so this you have to remember. This is a very generic block. This block number 8 is a very generic block where you can make different connections. For maybe you want to take some connections from the board to external world, or from external world to the board. For that, these terminals have been given to you. There is another provision in the board that is a very I should say good one, that is the power supply for a logic probe. They have given a completely different power supply for the logic board. Definitely this is same as the ground and 5 volt block you have seen there, but this section is completely dedicated to a logic probe. The logic probe I had already shown you. It has got these two terminals, 5 volt and ground, and you can see that the logic probe is working. Okay, so if I put the logic probe here, you can see that I will go for low. You can see it is operating as high, low, high, low, high, low, high, low, like that. Okay, this camera is not that fast, but you can see it's high, low, high, low, high, low thing is there. All right, and if I make it very high, if the frequency is very high, that is the clock frequency is very high, then you can see it shows pulse. It shows pulse. Likewise, if I connect it here, what it get actually? I have to just decouple it to ground. And see, if I connect it to a 5 volt, you can see high. If I connect it to 5 volt, you can see high. If I connect it to ground, you can see low. And by default, it remains in pulse condition. Okay, you can connect it here. You can see there is a high for a little bit of time. Fine. Now the most important part of this board, with which we will be conducting several experiments, is this switch block and this LED block. You can see these are these switches. They work as logic inputs, and these LEDs, they work as logic output. What does that mean actually? That means that if the switch, you can press the switch like this, the switch can be pressed like this, the switch can be pressed for keeping it on, or it can be pressed for making it off. You can press for keeping it on, you can press for keeping it off, like this. You can also here toggle switch, no problem. Now you see here, when the switch is not depressed, that is when the switch is in its released condition, then it is in high condition. It is in high condition. And when I press the switch, you can very easily see it becomes low. When I depress it, it becomes high. So that you have to remember. So let us do the experiment, a small experiment. The same LED, it is connected to the board. I am connecting it to ground. That is, the cathode of the LED is connected to ground. And what I will do, I will take one connection from here. I will take a jumper, because you can see for each switch there is a corresponding terminal from which I can take electrical throughput. So I will connect it here, and I will connect it to the resistance. Now as you know, the resistance is connected to the anode of the LED. You can very easily find the LED is glowing right now. Why the LED is glowing? Because the switch is not in pressed condition. So it is giving an output high at this terminal. The output high at this terminal. Now this high output of the switch is working as the digital high input to the circuit. So you can see here, this is high. Now when I want to make it low, I have to press the switch. When I press the switch, the LED is no more working. So that easily says that whenever the switch is not pressed, it is giving an TTL high, logic high signal, and when I press it, it gives a logic low signal. So whenever we want to build our circuit, these switches will help us to make a circuit logic low or logic, to make up terminals rather, logic low or logic high. Now every time, in order to see whether a particular terminal is at logic low or logic high, we need not to use an external LED. For that, these LEDs are already given. You can see there are 8 LEDs given, L1 to L8. So there are 8 LEDs given in the circuit, and accordingly there are 8 inputs. They are also given here. Now you can see that what is the role of this LED. Now you can see this switch, if I make it work, this is actually a logic output from the board. This is actually a logic output from the board. but for your circuit it's a logic input. Now whenever your circuit gives a logic output, that has to be connected to this LED. That has to be connected to this LED to ensure whether that output is in the status of logic high or logic low. Let us do something with that. Okay, so I will connect it here. I will connect an LED here, and I will connect its terminal here. Okay, I will remove this LED from the circuit because it is no more required right now. So I will connect it here at this point. This point I am connecting it. Okay, so next I would like to connect this switch so that its operation can be seen on the LED. I will connect the terminal here and I will connect it here. Okay, so now you can see this is a very simple series connection because they are interconnected. Now when I press the switch, you can see that LED is glowing. When I press the switch to depressed condition, it becomes logic 0. You can see here it becomes logic 0. Therefore the LED is not working. When I release the switch, it is state 1, the LED is working. When I press the switch, it is logic 0 condition. When I release the switch, it is logic 1 condition. Now this thing will happen with every LED. You can see like this. So therefore all LEDs, they work similarly. I hope it is clear right now. Now two things we have to remember here that is very important. One, each and every LED, when you connect them, you need not to connect an external series resistance, because this external series resistance is already connected inside this board. Within the trainer, a series resistance is already connected to the LED, so that whenever you give a signal to it, there is necessary amount of current that will reach the LED, and the resistance ensures that this current is not to that value which is enough to damage this LED. So this same series resistance is connected to each and every LED respectively, so that it is ensured none of the LED is damaged if you give a 5 volt output over there or 5 volt digital signal. Now you can see that the series resistances that are given inside this circuit, we cannot see them, they are given inside the circuit. Okay, they are given inside this board. They can handle a signal up to 5 volt. If you want to connect here a 12 volt or a 24 volt supply, that might damage the LED. Okay, next point is the switches. Remember, these switches are always pulled up. The switches are always pulled up. Pulled up means when you release the switch, that is connected to 5 volt. That is connected to 5 volt. Right? This connection is direct connection. That means one terminal of the switch is directly connected to the 5 volt. Now when you press it, it becomes 0. Okay, when you press it, it becomes 0. That means it is directly connected to 0 volt. Now remember that this switch is actually having 3 terminals. On one case your output is connected to 1, on the other case your output is connected to 0. Right, in the center condition, which is connected to the board, or it is giving the output to us, which is connected to this terminal, that terminal has to be connected. That terminal has to be connected through a resistance, either to ground or to 5 volt supply. Either to ground or to 5 volt supply. This is called pulling up the terminal or pulling down the terminal. So remember, in this circuit there is a pull up resistor that is being used to be connected to the 5 volt supply. That ensures whenever your switch is not pressed, then this terminal will be supplying you a 5 volt signal. When it is pressed, it is a 0 volt signal. Okay, so this is like that. Now remember that if there is a toggle switch, you can understand this phenomena very easily. But if you do not have a toggle switch, if you do not have a toggle switch, you have got toggle switch means SPDT, single pole dual throw switch, and you have got a switch which has got only two poles, right? On one side there is one pole and the other side there is one pole. So what you can do, definitely you can connect your terminal. Under that circumstance also you can connect your terminal to that switch. Remember that on one side it should be high and the other side it should be low. So when you put on the high or low side, remember to give a pull up or pull down. If you give a pull up, you need not to give the pull down. If you give a pull down, you need not to give a pull up. That resistance has to be connected so that your TTL circuit input does not get into a flapping mode. The flapping mode concept is very important because if you keep any terminal of the TTL IC open, then it may take some spurious signal and you will find that your circuit is behaving in some anomalous way that you cannot determine. You can think that I have connected it to low, then why it should work like that? Now, if you are connected it to low, remember, if any TTL terminal is connected to low, it has to be connected to low. You cannot keep it open. So none of the terminal of the switch cannot be kept open. It has to be either pulled up or pulled down. So in every case, we either make it pull up or pull down, because if you keep it on pull down status, then it is connected to ground through a resistance. The resistance value can be 4.7k to 10k, and if you connect it to supply, it can be directly connected to the supply. That means you can give it a hard supply. So that you have to remember while making any digital circuit with TTL ICs. This is one very interesting point that we need to remember, and this is all about this digital trainer. In the next session we will develop the logic, we will see the working of logic gates using this digital trainer. Thank you.